Welcome to week 6 in the Newtonian Mechanics Laboratory. We're discussing work and energy. The sum of all the works done on a system from external forces gives you the change in kinetic energy of that system. And this week, our system is the cart moving along a track. We have work done by the force of tension in this string. One end of the string is attached to a hanging mass. The other end is attached to the force sensors, so we can measure it. The displacement of this system can come from the motion detector on this end. So we can measure force and displacement, find the work done by that tension force. We can also find the kinetic energy as we look at the velocity from this motion detector data. Now, the work done by the tension and the change in kinetic energy don't equal in this case because there's another force doing work. We've added on the back of this cart a friction pad, and it's just a little felt pad that slides along the track, adds friction, which is a force in the negative direction with a positive displacement. That gives you negative work. So that takes away from our energy calculation just a bit, and we can figure out from the change in kinetic energy and the work done by the tension in the string, just how much work is done by that friction force. It would be great if we found a way to estimate the work done by the friction force in another way, and then we could compare to see if they're in experimental agreement. So that's our task for today. This week we are looking at work and energy in the Newtonian Mechanics Lab. I'll see you in lab. Look forward to working with you.